All right, number 9. We're going to graph the tangent. Y equals 4 times the tangent of 2 theta plus 90. All right, so tangent, remember, doesn't have an amplitude. So we're not asked to find the amplitude here, but we are asked to find the period, and we're asked to find the phase shift and the vertical shift. And all of this, the period and the phase shift, we want that in degrees. So the period, remember the period for a tangent function typically is 180 degrees. So our period here is going to be 180 degrees divided by this number right here, this 2. So 180 divided by 2 is 90. That's our period. The phase shift is this number divided by this number, so 90 divided by 2, so that's 45 degrees. And it goes the opposite direction of what we would expect since we're adding. This 45 degree shift is going to be to the left. And then the vertical shift, there is no vertical shift. We're not adding or subtracting anything to the whole function. So the vertical shift is none. All right, so the way that I like to graph tangent is to start off by graphing the center line, because remember the tangent function typically looks like this, and it's got this center point here, this point of inflection where it goes from concave down to concave up, right? So let's start by graphing that center point, or that point of inflection. We know it's going to be shifted 45 degrees to the left. So that's going to be over here, which is actually off of our graph. So instead of starting with that point, let's start, let's go one period forward, one period to the right. So let's just add 90 to that negative 45. And we'll be right over here at positive 45. So that's our starting point. Okay, now we need to find our asymptotes. So since the asymptotes are going to happen once every period, and the period is 90 degrees, so we're going to have an asymptote every 90 degrees. And this center point is right in the middle of two asymptotes. So to find this first asymptote, we're going to start at this center point, and we're going to go a half of a period to the left. And a half a period, so that's 45 degrees, a half a period to the left puts us right on the y-axis. So that's our first asymptote. And then we're going to have another asymptote, a half a period to the right. So 45 degrees to the right puts us at 90 degrees. So there are our first two asymptotes at the y-axis and at 90 degrees. And then from then on, we'll just keep having another asymptote every 90 degrees, every one period, going off that way and this way, off to infinity in both directions. So 90 plus another 90, another one period would be 180. And we'll have a center point right in the middle of those two as well, a point of inflection. And so now we can draw our tangent function. It's going to look like this. What this 4 is going to do is it's going to stretch our tangent function by a factor of 4. So it's going to be a little bit skinnier than our normal tangent function. For this rough sketch here, we're not going to be worried about exactly how skinny that's going to get. But your tangent should look something like this. So for the test, the things that I'm going to be looking for the most is that you've got the period, the vertical shift, and the phase shift correct, and that you graphed these asymptotes in the right place. And of course that you've got the tangent function going in the right direction. But I'm not going to be terribly concerned with how skinny or how squiggly these tangent lines are going to be.